NC State, it's my pleasure to welcome you all. You are here at the Mountain Horticultural Crops Research and Extension Center and Research Station. This is actually one of 18 research stations in North Carolina, and it's a little unusual in that we actually have faculty research programs located here off campus, so we're sort of the western outpost for NC State. We do have, up top is the Research Center, Research and Extension Center. It's got labs and offices and conference facilities. Down here we have farm and greenhouse operations. We've got close to 400 acres. I did want to introduce some local celebrities. Dick Burr is over here. Dick worked at this facility and has been retired 20 years now.
Just about.
But he is a past president of Eastern Region IPPS. A little bit of background. Being that we work for a university, we are very much involved in the land grant mission and the pillar of the land grant mission involved in teaching, research, and outreach. So we do train students. We do work a lot with industry groups, and we do quite a bit of research that ranges from fundamental work to, you're making me nervous, Bree.
Sorry.
Research varies quite a bit from fairly basic fundamental research to applied research, but most of it does revolve around our breeding program. So, for example, we might do some basic research on cytogenetics of Mahonia and look at determining different ploidy levels, but that informs our breeding programs and gives us valuable information and a foundation for doing our breeding work.
So this is an intergeneric cross between Catalpa and Chalopsis. So people are probably more familiar with Catalpa, right? But to have those awesome, like orchid-like flowers, you have to have space for a huge tree. So looking to Chalopsis linearis, which is a relative of the Catalpa that grows in the American Southwest, you can pick up a smaller habit and some landscape adaptability because it deals with some pretty harsh and dry soils out there. So here we've got, this is just a release for last year for some, we talk about these releases. Tom was just talking about how many plants we grow in a year. I think we talk on average to cross the plant, grow out the seed, evaluate it, trial and propagate it. It takes somewhere between 5 to 10 years on average, probably leaning towards the longer end of that to have an introduction. I think this one has been 17 or so years in the making, so this one's been around in the field for a while and we finally moved on it and we're excited about it. So you get a plant that's right there, a small tree or shrub, a dieback shrub further north that has some really nice, awesome flowers. So some of you have heard about it, and I know the Franklinia and our hybrids have made it out of the U.S. before, so maybe you've seen it in some other countries. But we've got our X-scored linea here, and it's actually in flower today if everybody wants to see it. So here's an X-scored linea, which is a hybrid between Gordonia lasianthus and the Franklinia I just mentioned. So, Franklinia is extinct in the wild now, and a big contributing factor to that is the Phytophthora that's kind of spread everywhere. So this intergeneric hybrid has a resistance to that, so you've got the conservation of this now extinct tree, Franklinia, in this package with Gordonia lasianthus, another native TAC, that's got some really interesting attributes, like these nice large fried egg flowers that are pretty fragrant, and it puts on some nice fall color that you can see.
It's got red flowers, Orion is white. Alysium, as you may know, are sort of dinosaurs of the plant world. They're members of the oldest lineage of flowering plants. As Bob Geneve can tell you, that it's often referred to as the anagrade or anitagrade group of plants. So it includes odd things like Amberella from New Caledonia, one of the first flowering plants, water lilies, and Alysium is in that same group. So predates magnolias by millions of years. They're fascinating plants that are generally, Alysium floridanum is generally found in the Gulf Coast, but it's quite cold hardy, can grow up into zone 6A. So most likely it was pushed south with the glaciers, with the Pleistocene glaciers, and just hasn't had a chance to radiate back up, but it's got quite good cold hardiness. We were breeding it to try and reinvent Alysium and enhance some of the landscape features. So we shrunk it down some. These are much smaller than a typical Floridanum. We brought in reblooming. You can see some of these are still in bloom all the way up to frost in the fall, so they bloom in the spring, take a little break and start reblooming. But they are native, broadleaf evergreens, very deer resistant, and quite cold hardy. So we think they've got a lot of utility in the landscape. Those are being sold by Star Roses and Plants.
My name is Andra Nuss. I'm a research specialist here with the program as well. We have had three Deutzia introductions in the past years. Yuki Snowflake was an improvement upon a Nico type white small flowered or small habit with profuse flowers. Yuki Snowflake has quite a few more flowers than Nico. It tends to bloom a little bit later than Nico, so miss some of those early frosts that Nico gets. And then the real breakthrough was Yuki Cherry Blossom, in that we created a pink Deutzia that's low growing and wonderful habit, wonderful pink flowers that are more pink on the back than the inside, but the color comes across really nicely on Yuki Cherry Blossom. And then we've had a third one, just recent introduction, called Yuki Kabuki, which is a little bit more pink and a little bit taller habit, a little bit bigger habit. So we continue to work on Deutzia to get more pink, better habits, fall color, but yeah, we're got some great releases out there too.
Yeah, good production plants. Cherry Blossom just branches, self branches, does have pretty good fall color.
Yeah.
It grows itself, so nursery.
So what we do is just tomato breeding and genetics, and tomato is a big industry in the United States, always top 3 vegetable in entire United States, sometimes first or second after lettuce or before lettuce or sweet corn. It's like $1.66 billion industry, but most of it's like processing tomato, mainly in California, like $1 billion industry, and lots of acreages goes to processing tomato in California. But then we have about like 30 or 40 acres of fresh market tomatoes, which we are focused on here, working on fresh market tomatoes. And fresh market tomato industry by itself is kind of 2 sections. One is called green harvest, which is mainly commercial production in Florida and a little bit here. They harvest tomato green and they store them, and then later on they gas them, and they usually sell them for fast food industry. But fortunately in North Carolina we have vine ripe industry as well, so they basically harvest when plants they show some sign of ripening in the fruit, and they sell it on the fresh market or in grocery store for like perfect examples of the disease in the tomato that we deal in our region and in the like in eastern North Carolina as well, and some of them is just worldwide everywhere, like Phytophthora, bacterial spot, or like early blight, and they present everywhere. So unfortunately they are natural resistant for them. So what we usually do, find natural source of those resistant and cross them. They are mostly wild tomatoes. The fruit look like small and like potato fruits. So we cross them with the tomatoes and try to select them for the resistant. It used to be like, this program actually is one of the best, maybe sometimes first or second tomato breeding program in the entire nation, actually worldwide. It started with Randy Gardner in 1976, and the other one is like University of Florida. And ever since, like, it's been the most important tomato breeding program.
Thank you all. This is a project that's been funded by the USDA Specialty Crops Research Initiative, and it's led by Tennessee State University, Dr. Carla Rodesso and Dr. Jason Oliver. And we're looking at flat-headed borers and all sorts of specialty crops, like pecans, walnuts, hazelnuts, blueberries, and ornamentals, which is what I'm looking at. And I am in Objective 4, which is try to identify production practices that might actually increase infestation, and then find some practices that would prevent infestation. In the U.S., red maples aren't normally budded or grafted onto their own rootstock because they're incompatible. So they'll normally take a rooted cutting and then of the desired cultivar, and then grow it in the field for a year, and then still stub it back so they can get the benefit of one bud and then 1 year's worth of a root system. So you can get 6 to 8 foot whip grown in 1 year. But that leaves a wound on the plant that then has to be grown over and protected. And when these trees are raised on the west coast and then brought to the east coast where we have lots of flat-headed apple tree borer, it's an open wound where the insect can lay its egg, and then the larvae can tunnel under the bark all summer, overwinter under there, and then burrow down into the stem and then exit through this sort of D-shaped hole. It's very difficult to control because the insect life cycle, the beetle that you would be trapping for, is not the one that does the damage. So once you actually find the beetle, you then have to prevent the egg laying on the stem. And the egg is laying on the stem, and then the larvae just sort of hatches and bites through the egg and is in the stem immediately, and you're not seeing anything. Like you can't see anything. And the beetle is just some nondescript sort of brownish black beetle that emerges sometime between Mother's Day and Father's Day and lays eggs in a number of trees. We're not even sure how the whole process works. We're just sort of working on. So what I found is, in some growers essentially plant trees randomly. And I went through a field and about 60% of the trees were infested with flat-headed apple tree borer. But they only infested it right at this stubbed area. They laid their egg right at the stubbed area, and then it sort of ate around that area because it's an open wound, it's easy access. And then they found out if this stubbed area was facing south and it was nice and warm, since they got to spend the whole entire winter in this, they were like 60% more likely to lay their egg on the south side of this tree if the stubbed bud union was facing south. If it was facing north, only 20% of the time they would lay their egg there, even though it's an open wound. They would always choose a south-facing open wound.
It's actually kind of a funny story. Like many rhododendron-obsessed plant breeders, we actually started our Evergreen azalea breeding program trying to figure out how to get yellow from deciduous azaleas into evergreen azaleas. We're actually still working on that. It's been about, 20, 25 years. We think we're making real headway though. But in the background, when we were kind of looking at which evergreen azaleas we wanted to kind of use for that very complicated work, we started looking around at some of the evergreen azaleas that were available. And while there's been a lot of breeding in evergreen azalea, and there's been a serious improvement over the last 20 years in the types of azaleas you can get and the color forms and the size, they just weren't surviving up here for us very well. They'd last for us for a couple of years, and then they just wouldn't persist through one of our winters. And we're going to talk about it a little bit more up in the field, but we're kind of in a perfect location for screening for cold tolerance for the deep south. And so we started looking at a bunch of different cultivars and species in evergreen azalea, and then the evergreen azalea program just kind of grew out of that.
Fine Hydrangea arborescens. It tends to bloom on new growth versus your Hydrangea macrophylla, which like an Asian hydrangea, tends to set its flowers in the fall, so they're setting its flower buds now. And so if you happen to live in a region where you get late spring freezes, you won't have any flowers really on the regular Hydrangea macrophylla. However, Hydrangea arborescens, since it blooms on this year's growth, it's pretty cold hardy, doesn't really matter. Even if it gets killed to the ground, it'll grow new stuff and flower. So it's a pretty reliable flowerer for anywhere where you have a kind of erratic cold late in the spring. The story, our former student, Dr. Richard Olson, now the director of the National Arboretum, he happened to have a kind of a chance discovery while he was hiking out west of here, 2 hours west of a Hydrangea arborescens. The wild type is a lace cap, which is fertile flowers kind of surrounded by a veil of sterile florets. And he found one that had ever so slight hint of pink in the sterile florets. They're normally white. The wild type is white. And so we're like, oh, as plant breeders, that's interesting. Collect that. Bring it here. Then we start asking questions. Is it a somatic mutation or is it heritable? So do some test crosses, determine that it is in fact heritable. Then in the trade at the time, there was one called Echo Pink Puff, which is, it had no sterile florets. It was 100% fertile florets, but it had some pink in the bud before they opened. They were pretty strongly pink, almost like a pretty strong pink, like not quite red, but definitely more than pink. And so we're like, well, is that allelic or maybe it's a different gene? So once again, do some test crosses, and it turns out it's allelic. Oh, sorry, that is two different genes. which is great because now we can think about maybe stacking those two genes to make it even more pink. And then we bring in the mop head from something like Annabelle Hydrangea, which is an arborescens. It had the mop heads are all sterile florets. Annabelle is a beautiful plant. It's been growing in this country a long time. It's a nice white mop head. A lot of people here, anywhere that it rains and we have some mud, people call it a mud finder because the big sterile floret heads get a little wet and they're right into the mud. So one of our challenges was to make a pink one and then see if we can stiffen the stems. So we were successful for a number of years of crossing. We released the first pink mop head arborescens Invincible Spirit. We have since replaced that with Invincible Spirit 2. Those happen to be, we have a campaign of $1 for every plant of that sold. It goes to the National Breast Cancer Foundation to support breast cancer research. And John Reuter out of Georgia, University of Georgia, he created years ago a green fastigiate, and they called Sky Pencil. It's been a big seller over the years. And we had the idea, well, wouldn't it be kind of fun to have a yellow one of those? So this was our first attempt, and it's kind of yellow. We were really impressed with this plant when we created it because it's 100 times more yellow than actual Sky Pencil. But our commercial cooperators, they were less enthralled than we were about the yellow on that. They said it needs to be more yellow. Well, we had the name. We were going to call it either like number 2 or glow stick. So glow stick kind of stuck, and we've been saving it. So anyhow, we're now into this range here. These are our glow sticks. They have been released in the name Ilex glow stick, and they're much more yellow. The yellow is the sun. It's a UV response. So if you have grow them in a shady environment, and as you can see when you open the plants up, they're all green, but it's a UV response. And then this one down here, it's also being released at the same time, Glow Pop.